There are 4 types of gRPC. In this lecture, we will learn how to implement the simplest one, unary gRPC. We will use Golang in this video and Java in the next one. Here's the plan. First, we will define a proto service that contains the unary gRPC to create a laptop. Then we will implement the server to handle the request and save the laptop to an in-memory storage. We will implement the client to call the RPC and write unit tests for the interaction between client and server. And finally, we will learn how to handle errors, return suitable gRPC status codes, and how to work with gRPC deadline. Alright, let's start. I will open the PCBook project with Visual Studio Code. First step, we will create a new laptop service.proto file. The syntax, package, and options will be the same as the other files, so I just copy and paste them here. We're gonna need the laptop message, so let's import it. Next, define the create laptop request. It contains only one field, the laptop. Then the create laptop response. It also has only one field, the ID of the laptop. Now the important part. We will define a laptop service with the keyword service. Then inside it, we define a unary RPC. Start with the keyword Rpc, then the name of the RPC is create laptop. It takes the create laptop request as input and returns the create laptop response. End it with a pair of curly brackets and a semicolon. And that's it. Pretty easy and straightforward. Now let's open the terminal and run makegen to generate the codes. The laptop service.pb.go is generated. Let's take a closer look. This is a create laptop request struct. It has a function to get the input laptop. This is a create laptop response struct. It has a function to get the output ID of the laptop. This is a laptop service client interface. It has a function create laptop, just like how we defined it in the proto file. Why is it an interface? Because it will allow us to implement our own custom client. For example, a mock client that can be used for unit testing. This laptop service client struct with a small letter L is a real implementation of the interface. You can see its implementation right here. Next, this is a laptop service server. It is also an interface with no implementation. Basically, we must write our own implementation of the server, but it must have the create laptop function as defined in this interface. Here's the function to register the laptop service on a specific gRPC server so that it can receive and handle requests from clients. Okay, now let's implement the laptop service server. I will create a new service folder and create a laptop service.go inside it. I will declare a laptop server struct. Write some commands for it. Then a new laptop server function to return a new instance. Now we need to implement the create laptop function, which is required by the laptop service server interface. It takes a context and a create laptop request as input and returns a create laptop response with an error. Write some comments here. This line looks too long, so I'm gonna break it down to make it easier to read. First, we call getLaptop function to get the laptop object from the request. Then we write a simple log saying that we have received a createLaptop request with this ID. If the client has already generated the laptop ID, we must check if it's a valid UUID or not. To do that, we will use Google UUID package. Search for Golang Google UUID on the browser. Open this GitHub page. Copy this go-get command and run it in the terminal to install the package. Okay, now we can use uuid.parse function to parse the laptop ID. If it returns an error, then it means the provided ID is invalid. We should return a new response to the client together with an error status code. For that, we can use the status and code subpackages of the gRPC package. In this case, we will use the invalid argument code because the laptop ID is provided by the client. We send the code with a message and the original error. If the client hasn't sent the laptop ID, we will generate it on the server with this command uuid.newRandom. If an error occurs, we return it with a code.internal, meaning an internal server error. Else, if everything goes well, we just set the laptop.id to the generated random UUID. There's a type mismatch, so we have to convert the UUID to string here. Alright, normally after this, we should set the laptop to the database, but this is a course about gRPC, so I just want to focus on it. Therefore, to make it simple, I will just use an in-memory storage. It will also be very useful for unit testing later. Let's add a laptop store inside the laptop server struct. Then create a new laptopstore.go file inside the service folder. As we might have different types of store, I will define laptop store as an interface. It has a save function to save a laptop to the store. Then we will write an in-memory laptop store to implement that interface. Later, if we want to save laptop to the database, we can always implement another db laptop store to do so. Okay, back to our in-memory laptop store. We will use a map to store the data, where the key is a laptop ID and the value is a laptop object. There will be multiple concurrent requests to save laptops, so we will need a read-write mutex to handle the concurrency. Now, let's declare a function to return a new in-memory laptop store and initialize the data map inside it. Then implement the save laptop function as required by the interface. First, we need to acquire a write log before adding new objects. Remember to defer the unlock command so that we won't forget. Check if the laptop ID already exists in the map or not. If it does, just return an error to the caller. I will define an exported error variable here so that it can be used from outside of this service package. Now, if the laptop doesn't exist, we can go ahead to save it to the store. To be safe, I will do a deep copy of the laptop object. Let's open the browser and search for Golang copier. Copy this package path. and run go get in the terminal to install it. Now create a new laptop object, call it other. Then call copier.copy to deep copy the laptop object to other objects. If an error occurs, just wrap the error and return it. Otherwise, just save the other object to the store data map. Alright, let's go back to our laptop server. We can call server.store.save to save the input laptop to the store. If there's an error, return cost.internal with the error to the client. We can make it clearer to the client to handle by checking if the error is because of the record already exists or not. Simply call errors.is function. If it's true, just return already exists instead of internal. Finally, if no errors occur, we can write a log here saying that the laptop is successfully saved with this ID. We create a new response object with the laptop ID and return it to the caller. And that's it for the server. Now I'm going to show you how to test it. Let's create a laptop server test.go file. The package name is service test. Create a function test server create laptop. Make it run in parallel. I want to test many different cases, so let's use table-driven test. First, I will declare all test cases. A test case will have a name, an input laptop object, a laptop store, and an expected status code. The first case is a successful call with a laptop ID generated by the client. So the laptop will be a sample.newLaptop. Store is just a new in-memory laptop store, and the expected code is OK. The second case is also a successful call, but with no laptop ID. I expect the server to generate a random ID for us. Let's create a laptop no ID object by generating a sample laptop and set its ID to empty string. The third case is a failed call because of an invalid Uuid. Let's create a laptop invalid ID object by generating a sample laptop and set its ID to invalid Uuid. This case, we expect the status code to be invalid argument. The last case is a failed call because of a duplicate ID. We will have to create a laptop and save it to the store first, then call createLaptop function with that laptop's ID. We expect to see an already exists status code in this case. Okay, let's create a laptop duplicate ID as a sample laptop. Make a new in-memory laptop store. Save the laptop to the store and check that there's no error returned. Alright, the test cases are ready. Now we iterate through them with this simple for loop. Save the current test case to a local variable. This is very important to avoid concurrency issues because we want to create multiple parallel subtests. To create a subtest, we call t.run and use a tc.name for the name of the subtest. Call t.parallel to make it run in parallel with other tests. Then we create a new createLaptop request. With the input is tc.laptop. We create a new laptop server with the in-memory store. But wait, Looks like I forgot to take in the laptop store in this new laptop server function. So let's add it. Now we can pass the tc.store to this function to create a new laptop server. Then just call the server.createLaptop function with the background context and the request object. The successful case, or when tc.code is OK. In this case, we should check there's no error. The response should be not nil. The returned ID should be not empty. And if the input laptop already has ID, then the returned ID should equal to it. The failure case, when tc.code is not OK, we check there should be an error, and the response should be nil. Now we want to check the status code. Let's call status.fromError to get the status object. Check that OK should be true, and status code should equal to tc.code. Then it's done. Let's run the test. Yay, it passed. Also run the whole package test and check the code coverage. 93.5% is a very high coverage. However, the test that we have written didn't use any kind of network call yet. They're basically just a direct call on server side. Now I will show you how to test the Rpc request from the client side. Let's create laptop client test.go file. The package name is still service test, but the function name is now test client create laptop. I will make it run in parallel as well. First, we need to start the gRPC server. I'm gonna write a separate function for this. It will take the testing.t as an argument and return the laptop server object together with the network address string of the server. In this function, we create a new laptop server with an in-memory laptop store. Create the gRPC server by calling grpc.newServer function. Then register the laptop service server on that gRPC server. We create a new listener that will listen to TCP connection. The number 0 here means that we want it to be assigned any random available port. Now we just call grpc server.serve to start listening to the request. This is a blocking call, so we have to run it in a separate Go routine, since we want to send requests to this server after that. Okay, now just return the laptop server and the address string of the listener. In the test, we call this function to get the server and its address. Then we will create another function to return a new laptop client for test. This function will take the testing.t object and the server address as its arguments, and return a pb.laptopServiceClient. First, we will dial the server address with grpc.dial. Since this is just for testing, we will use an insecure connection. Check that there is no error, and return a new laptop service client with a created connection. Next, we create a new sample laptop. Set its ID to a variable to compare later. Create a new request object with a laptop. This time, we use the laptop client object to call createLaptop function. Then we check that no error is returned, and the response should be not nil. The returned ID should match the expected ID we saved before. Now we want to make sure that the laptop is really stored on the server. To do that, we need to add one more function to the laptop store. It's a find function to search for a laptop by its ID. It takes a string ID as an input and returns a laptop object with an error. In this function, we first call mutex.rlock to acquire a read log. Remember to release it with a defer command. Now we can find the laptop from the store.data map by its ID. If it's not found, just return nil. Else, we should deep copy it to another object by using copier.copy as we did before. Returns an error if it occurs. Otherwise, if everything is good, just return the copied object. Now go back to our client test. We call laptopserver.store.find to find laptop by ID. Check there's no error, and the laptop should be found, so it should be not nil. Finally, we want to check that the saved laptop is the same as the one we sent. I will write a separate function to check this. It will have three inputs, the testing.t object and two laptop objects. Now, if we just use require.equal function for these two objects and run the test, it will fail. It's because in the laptop struct, there are some special fields that are used internally by gRPC to serialize the objects. Therefore, to compare two laptops properly, we must ignore those special fields. One easy way is just serializing the objects to JSON and compare the output JSON strings as I'm doing here. Now, if we run the test again, it passed. Excellent. Next, we will implement the real server and client. First, I will delete this unused main.go file. Then create a new CMD folder. In this folder, let's create one folder for the server and one folder for the client. The server will have its own main.go file. Let's paste a simple hello world program here for now. Similar for the client. Now I will open the make file and change this run command into two commands. The server command to run the server main file and the client command to run the client main file. Let's change the content of the hello message a bit to make them different. Let's say hello world from server and hello world from client. Alright, let's try it. Run make server. Then make client. Perfect. Now let's implement the real server. We need a port for the server, so I use a flag.int to get it from command line arguments. Parse the flag and print a simple log. Similar to what we wrote in the unit test, we create a new laptop server object with an in-memory store. Then create a new gRPC server. Register the laptop server with the gRPC server. Then create an address string with the port we get before. We will listen for TCP connections on this server address. Call gRPC server.serve to start the server. If any error occurs, just write a fatal log and exit. That's the server code. Now we have to update the make file to send the port argument to the server program. I will use port 8080. Let's test it in the terminal. Make server. The server is started on port 8080. Now the client. First, we will get the server address from the command line argument and write a simple log saying we are dialing this server address. We call gRPC.dial function with the input address and just create an insecure connection for now. If an error occurs, write a fatal log and exit. Else, create a new laptop client object with the connection. Then generate a new laptop. Make a new request object. And just call laptopClient.createLaptop function with a request and a background context. Similar to what we wrote in the unit test, if an error occurs, we convert it into a status object so that we can check the returned status code. If the code is already exists, then it's not a big deal. Just write the normal log. Else, write a fatal log. In any error cases, we have to return here. If everything is good, we simply write a log saying the laptop is created with this ID. Okay, let's run it in the terminal. The server is already running. Now open a new tab and run make client. Oops, it failed to dial server because the address is missing. I forgot to update the make file, so let's open the file and add the address argument to the client command. Now let's go back to the terminal and run make client again. This time the laptop is successfully created. On the server, we see two logs, one saying it has received a request with this ID, and the other saying the laptop is saved with the same ID. Now what if the client doesn't send ID? In the client main file, I will set laptop.id to an empty string and rerun the client. A laptop is still created with this ID. On the server side, we also see two logs, but this time the ID in the first log is empty. It means the server has generated a new ID for the laptop. Let's try to send an ID that already exists to see what happens. I will copy this ID and paste it in the client code. Rerun the client. This time it says that the laptop already exists. On the server side, there's only one log for receiving the request. Let's try one more test with an invalid Uuid. I will change this laptop.id to invalid and run the client again. It's a fatal error message with a status code invalid argument. Excellent. Next, I'm going to show you how to set timeout for the request. In Go, we will use context to do this. On the client side, instead of using context.background, I will call context.withTimeout and pass in a background context together with the duration of time, let's say 5 seconds. The function returns a context and a cancel object. The The context is used in the createLaptop function, and we defer the cancel call before exiting the main function. On the server side, let's pretend that we have to do some heavy processing here, and it takes about 6 seconds. Now let's restart the server and run the client. After 5 seconds, on the client side, we get an error with deadline exceeded code. However, on the server side, the laptop is still getting created and saved. It might not be the behavior that we want. If the request is cancelled before the call to save laptop to the store, we want the server to stop saving the laptop as well. To do that, we have to check the context error on the server. If there is a deadline exceeded error, we will print a log here and return a status error code deadline exceeded to the client. Okay, let's restart the server and rerun the client. The client still gets this deadline exceeded error, but this time the server also has a log saying deadline is exceeded, and it doesn't save the laptop to the store anymore. Now I wonder what happens if we cancel the request by interrupting the client. Let's run the client, and after 1 second, press Ctrl+C to stop it. On the server side, we still see that the laptop is saved. This is also not what we want, because the client already cancelled the request. To fix this, we will go back to the server and add one more check before saving the laptop. If the context error is context.cancelled, then we just log it and return an error with status code cancelled to the client. Now if we restart the server and rerun the client, interrupt it with Ctrl+C, then this time on the server, we will see a log saying that the context is cancelled and no laptop is saved to the store. Exactly what we wanted. And that's the end of this coding session. We have learned a lot about how to implement and test a unary gRPC request with Go. In the next lecture, we will learn how to do the same thing with Java. Until then, happy coding, and I will see you later.